Hello, my name is Jasia Kajfas. I am part of Hojjatie's statics class for spring term of 2024 at Valdosta State University, and I am explaining this method of sections problem as part of my final exam. Now, our problem statement is determine the force in member EB of the roof truss shown in Fig 618A. Indicate whether the member is in tension or in compression. Well, so we're given this model, and the first thing we see, we could probably cut across here, but that wouldn't work because we have three unknowns, but we can't use moment calculations since they meet at the same point. So we have two equilibrium equations we can use. That'll leave one unknown left over. So instead, we're going to cut across here so that we can get the calculation of a member that's part of this group so that we can solve for the EB when we cut across this section. Generally, you'd write the full body diagram of a truss, the entire truss first, but since there are no reactions, they essentially did it for us in this figure. So we're going to go ahead and make a free body diagram of the first section, section A. All right. This is the free body diagram of section A. We have our forces listed. And we're going to approach this by trying to figure out FED so that we can find FEB with our second section cut. And the way we're going to do this is using a moment calculation around point B. Let's look at point B. And you can see FEB, FFB, and FAB all meet at B. FED is left out, so it doesn't get canceled out when we calculate moment. So we do this moment calculation and we come up with FED, which is 3,000 newtons. And that means the member is under compression. Now that we know one of our knowns, we are going to go ahead and make our second sectional cut. And we're going to have FEF, FEB, our goal, and FED, which is 3,000 newtons, as we know. Can't forget that external force either. Now we have plenty of equilibrium equations to choose from. I used f of x first so that I could find FEF, which is 3,000 newtons, and that means the member is under compression. Then I used f of y using what I learned with FEF to get FEB. That's our goal. So if you calculate it, you get 2,000 newtons and the member's under tension. And you want to summarize it like this at the bottom, where you draw that member in tension and list out the value. But I hope you learned something from this video, and that sometimes you have to do more than one sectional cut to get what you need.